Hey, hi guys, this is Hemant, and today we are going to solve daily question from the Leetcode problem number 1405, longest happy string. So the string is called happy if and only if it satisfies all these necessary conditions. And let's just read these conditions. String can contain, contains only A, B, C, and it does not contain A. Okay, the string should not contain three consecutive of any of these above characters, whether it's A, B, or C, and they will be given the frequencies of A, B, and C. You can use at most of those frequencies and make happy string. And the goal is you need to return the longest possible happy string without violating any of this particular condition. So let's just read the input. So let's just say A is 1, B is 1, and C is 7. So we can use two C's and then one A, and then two C's, a B, and then two C's. Why not use the other C? Because we only using six C's. If I use, let's just say if I use one more C, then I'll be violating that there is a substring containing three consecutive letters of this character C. So I shouldn't do it. The only reason is you can use at most occurrences. Let's just say C is 7, right? At most instance you can use 0 to 7 occurrences of C. So the goal is to make this particular string, and there can be a many combinations. See, it's not just that you can use A here and B. You could have used B here as well. Okay, B here as well, and then A here as well, and that will be also valid combination because we are not violating any of this particular condition. So until unless we are violating these conditions, it's an happy string. So how do we do it? See, reading inputs is very important. Always, you need to see if there is any particular logic or trick whether lies in between these inputs. They always give these inputs so that you might figure out a way to solve it. That's why they'll choose these particular inputs. It's not just to make you understand how they're arriving at the solution, also they're trying to convey that see if there is any hidden trick or if any combination that makes sense, so that you can come up with any intuition without staying blank. See, even I haven't solved this problem yet, and this is something new for me as well. So yeah, if you see here, C is the most helping character. Whichever character, right, which has most frequency, I'm just thinking greedily. See, I'm just trying to solve it with my intuition. Like whenever I see C is contributing more to make it as longest happy possible string. So what if I say I'll use two C's? I cannot use one more C because it will be violating. So I can choose any one of these. Okay, any one of this. After that, again I can use two C's until I exhaust completely C's, or until unless I violate this particular condition. So I can use two C's. So previously we used A, and then now B is left. I'll use B, and A and B are exhausted. I can no further long use A or B occurrences. So still there is three occurrences of C. I'll use two occurrences of C, and then I'll see if I can have any more of the combination of A or B. Since there are no more left of A or B, so I cannot use this particular combination. I'll just have to end the string. So how do we actually do it? See, coming up with this greedy approach using the max two times, and then using the other character, and then again continuing with until unless you exhaust the max occurrence of any of this particular character is a one way to go. But this problem is not in the medium. It's somewhat implementational, and also it's somewhat slightly medium to hard difficulty. It's not actually medium because it's not very easy to implement this particular solution, though we have approach greedy will work here. So see, A is 7. I'll use two A's. I'll use any one of these character, so only B is left. I'll use B, and then again I'll use 2, and I'll see if I can use B or C. There is no more left, so I can just end. See, greedy will work here, but how to implement is something else. Okay, so yeah, this is the intuition. And since we already discussed, I hope you understand the problem, how we are going to solve it. So let's just think of intuition. So in order to use C very frequently, right? Like I need to keep track of C's, B's and A's in a sorted format, right? Which is the best data structure? Priority queue, right? So if I use priority queue, I don't have to sort again and again. It will by default sort and give me the most occurring character so that I can use it 2 times. And also after using it 2 times, how do you think I can actually use A or B? I need to see if the third character, I will take the C and compare with previous 2 characters. If it is again C, then I need to get the second most highest character and then use them. Again I'll continue with, I'll push the new frequency counts, and then again I need to come up with, until unless I exhaust C, I keep on doing this operation. So yeah, that is pretty much for the explanation. We'll just build with the code. I think you guys will understand even much clearer. So let's get into the code. So for this I need class pair. Why pair? Because I need character and its count, right? We need count, we need character. So we have count and character. So this is just normal class initializing the count and the character. And also you see, I need to sort it based on its occurrences, right? Every time I need to sort it based on occurrences. So I just kind of implement my own sorting way, comparable. So those who are not familiar with comparable, it's just a way to sort, custom sort with your own implementation. So yeah, you can search in Google and learn something about comparable. Because see, if I don't do my own custom sort, it's very hard to in Java there are primitive sorting techniques, but for custom classes and other sorts you need to use comparable or comparator. So it's very easy to use comparable and comparator. I'm just choosing comparable, it's just a choice. You can use the other one around as well, not an issue. So I need to compare okay, the new pair. How am I going to compare? Because I need to store it in highest, it's like MaxHeap. So I just say p dot count minus this dot count. It's just a decreasing way to sort it. Okay, I think this class is ready. So let's just bring our priority queue. Oh god. Okay, and we are going to choose pair. This is a MaxHeap. Okay, it by default, see, since we are using this class, it will understand by default you need to use this comparable, as well as the way to use this method is using this particular logic. So yeah, now the second thing is I need to I need to insert these A, B, C's in my priority queue. So, and also I only insert if the count is greater than 0, because if it is 0, there's no point of inserting it, right? So I'll just check, if at all A is greater than 0, I am going to insert it. Insert its count with its character. Let's just copy this thing because we're going to use 3 times, so it's better to do it. So if B is there, I'm gonna insert B, and if C is greater than 0, I can insert C as well. Okay, so this is all done. our sorting, the way we need to sort is done, and we already inserted into our MaxHeap. Now we can get into the real implementational part. So I'm going to use a string builder because strings in Java are immutable. So if you want to do anything, you need to use string builder to manipulate the strings. So I'm considering this as an answer. So I need to perform operation until unless I completely exhaust the priority queue, or until unless I violate any of these particular conditions which we were discussing, these conditions. So in the end we need to return the answer, that is for sure. Okay, now we'll do while priority queue has some occurrences, right? It has some occurrences. What you need to do is you need to get whatever the maximum occurring. Now initially, if you consider for this example, C will be at the top, right? We need to get that particular thing. How we are going to get? Pair first occurring thing. We're going to remove it. After removing it, and also see, I need to see if whatever I'm using character, right, it should not match with previous two characters if the length of this answer is already 2, because I should not violate the condition that using 3 characters I should not do that particular thing. So I need to be very careful also for that. Since we are dynamically appending characters in the answer, the length will vary. So based on that particular length we need to generate the answer. So I'll just get the current length. Okay, current length, and now I need to get the count. Okay, count of this particular thing, that is first dot count, and also what character it is, that is first dot ch. And now I need to check, okay, if at all length is actually greater than or equals to 2. That means okay, I can actually look previous two characters before inserting it, and I need to see, okay, yeah, I need to check if this character is matching with the previous two character. That means answer at char at n-1. Okay, n-1 is C, and answer at previous two characters n-2. If both these characters actually match, okay, if they actually match, that means I cannot use this character. Now I need to check for the second most character. That's the thing, right? See, just imagine that till here we have inserted. Now again I'm with C. So I need to see if all these characters or previous two characters are C or not. If I see that all these characters were already used, so I need to come up with the second most highest. Here B is 1, A is 1. We can use any one of them. So I'm going to use any one of them. Before that I need to check if it is available. Okay, if let's just say there is at some point, see here, if you come here CC and then again you're seeing for second most character, but there is no such thing. So in that case you need to break. So that's the condition here, right? If that is the case, there is no point in doing so. If not, yes, there is present, that is second, and we can take it out, and now we can use this particular character in the string. So we can actually append this character, and we can decrease its count. And only if and only after decreasing count still it has some frequency, then only we can insert back in the priority queue. If it becomes 0, there is again no point of inserting it, right? That's the thing. So if at all after decrementing Still if it's as some occurrence, then we can actually push it back with its occurrence and then the character. So this is pretty much it. If and only we discuss this particular condition, right? Now if not, let's just say if the length is still 1, or if let's just say it's not matching with two, it's only matching with one character but not two characters. In that case, all we need to do is we use the current character, that is first dot ch. We decrement its count as well, and again if and only if, okay, after decrementing, if it still has the occurrences, then we are going to push back to the priority queue. So first dot count and first dot ch. So I think, yep, that's pretty much it. Let's just run and see if it actually works, or if I made any silly mistakes or something like that. Okay, what am I doing wrong? My bad. It's empty. Okay. Okay, where are we getting wrong? CCAB. Okay. Let me just see if I made somewhere again a silly mistake, some kind of silly mistake. Okay. Just use this character. Right. This is where I actually made mistake. Let's just run and see if it works or not. Yep, there you go, it works. And why it's I forgot. See, if it is this condition, okay, you're using the second most, we are keeping hold of the first most, we are not using it, okay, and then we are going to use this character. We need not to push it before there only. It's either, you see, it's either this condition or it's just we have used only one character. After doing those particular, satisfying these two conditions, we'll check whatever we are keeping hold of the first one, right? If at all, if its occurrence is greater than 0, only then only we'll push it back. I think, yeah, we'll submit and see if it actually works for all test cases or not. Okay, you can see it works for all the test cases, 1 millisecond. Okay, it's time to discuss the space and time complexity. As you can see, the space complexity is like a plus b plus c, because we need to store all the occurrences, or you can just say it's very constant because we are only storing a, b and c, only 3 nodes. If you compare it as nodes, we are only storing 3 nodes. We are not care about how many occurrences are there, since the occurrences also it will be only till 100. It does not exceed that particular thing. And regarding time complexity, since we are using periodic queue, every time we pull we remove and add, it will take a logarithmic time. Since we are doing at most a times b times c times, the time complexity will be around a plus b plus c at most. At the worst case, we're going to use all the characters, so we need to pull out, we remove add, so logarithmic plus logarithmic, it will become kind of linear by doing this many operations. So yeah, I hope you like the video. I think you understand the approach and the implementation. This is something new to me as well. It's not very easy to come up with implementation, but yeah, hope you like it. If you do like it, you can like the video. We'll see you in the next video.